Hi there, this is Mr. Waterman again, and today we're going to explore exponent laws, just a little bit more than what we have been. Last class we went and did a little activity. You didn't have a flip for that day, and we had a little bit of a game playing with some dice, and we looked at exponents, all right? So we're going to look into it again, and we're going to look at these tables, and we're going to look for some patterns. So let's start off with this first one here. We've got 2 to the 4 to the exponent of 3. Well, what does that mean? Well, it means that we have 2 to the 4 times 2 to the 4 times 2 to the 4. We have 3 of them. Well, if we wrote that as a product of factors, all right, it would look like this. 2 times 2 times 2 times 2, that's 4 of them. And then we have it times it by 2 times 2 times 2 times 2, and that's another 4. And then we have 2 times 2 times 2 times 2, and that's another 4. Well, how many 2's do we have altogether? We have, if we count them up, we get 12. And you'll notice that if we multiply 4 by 3, we get 12 right over here. So let's try this next one. We've got 3 squared to the exponent of 4. Well, what does that mean? We have 3 squared times 3 squared times 3 squared times 3 squared. We have 4 of them. Well, what does that mean if we wrote it as a product of factors? Well, we've got 3 times 3, and we've got 3 times 3, 3 times 3, and then we have another 3 times 3. All right, well, how many 3's do we have altogether? If we count those up, we have 3 to the exponent of 8. And if you look at, if we multiplied 2 times 4, we get 8. Now again, if we've got a negative in there, this negative, we've got negative 4 in brackets to the exponent of 3 all squared. Well, what does that actually mean? Well, we've got negative 4 to the exponent of 3 times negative 4 to the exponent of 3. And if we multiplied that out into product of factors, it would look something like this. Negative 4 times negative 4 times negative 4 times negative 4 times negative 4, and finally one more time, times negative 4. All right, so what is that saying? Well, we have negative 4 in brackets, and if we multiply 3 times 2, we get 6. And we have 6 negative 4's there. All right, let's try it again. Actually, I'd like you to try this one. Negative 5 in brackets to the cubed and cubed again. Try that one on your own. Next, we've got numbers inside of brackets being multiplied. Well, we've got 5 times 2, or 2 times 5, cubed. Well, it means that we have 3 of them. Well, we could also, if we write it as repeated multiplication, just like we have in the past, we have 2 times 5 times 2 times 5 times 2 times 5. A product of factors, we have 2 times 2 times 2 times 5 times 5 times 5. Well, how many 2's do we have? We have 3. And how many 5's do we have? 3. Which is just like saying 2 to the 3 times 5 to the 3. All right, let's try this next one. We've got 3 times 4 times 3 times 4, because we have 2 of them. Well, if we write that as a product of factors, we get 3 times 3 times 4 times 4. How many 3's do we have? We have 3 squared times 4 squared. All right? Try those next two. And after you do that, I want you to pause the video right now, and I want you to try those out, and then we're going to look at the patterns. All right? So in number 1, the pattern that we see is we multiply the inside exponent by the outside exponent. And this is, we keep the base, and this is called power of a power. And for our second example there, we keep the exponent and apply that exponent to both bases. To both bases. And this is called power of a product. All right. So now let's go into the definition of a power of a power. When a power is raised to another power, so basically, power of a power is when a power is raised to another power. And so let's get an example here. We have 3 to the exponent of 5 to the 3. Well, when a power is raised to a power, and we talked about this already, and we're going to just multiply these powers. And so 5 times 3, and we get 3 to the exponent of 15. Wow, that's a big number. The exponent law for power over power is we keep the base and multiply the exponents. And if we want to do this with some variables, we're just going to get a to the m, and all that is to the n. Well, it just means that we're going to get a to the m times n. All right, let's turn the page. The power of a product is we taking the power of the terms that are multiplied. All right, so for example, we have 4 times 2 to the exponent of 7. And what we can do is, this is just like saying 4 to the exponent of 7 times 2 to the exponent of 7. All right, so the exponent law for product of a power is we apply the power to each of the bases in the product. And we just did that right there. All right. Next, we're going to go to power of a quotient. Now, we talked about power of a product, or law of a product power, but quotient is when we divide things. All right. So let's expand this knowledge. The power of a quotient is taking the power of numbers that are being divided. All right, so for example, we've got 5 over 2 to the exponent of 4. Well, I like to think of little invisible ones right there. And what that can do for us is, well, what's 4 times 1? 4. And what's 1 times 1? 4. I mean, 1 times 4? 4. So really, we're talking about 5 to the exponent of 4 over 2 to the exponent of 4. You can see the 4 affects each exponent with that number. So the exponent law for power of a quotient is we apply the exponent to both bases in the division. So let's try a couple examples. Well, first off, we've got negative 7 cubed to the exponent of 2. Well, what we're going to do here is we're going to multiply our exponents, and we get negative 7 to the exponent of 6. All right, so let's do this. We've got our negative on the outside right here. So our final answer is going to be negative no matter what. Well, what we're going to do is we're going to use the same base. We've got negative 2, and 4 times 5 is 20. Right. Next, 6 squared to the exponent of 7. We're going to multiply our exponents, and we're going to get 6 to the 14. Next, oh, look what we have here. We've got to do bedmass. All right. So we can either multiply what the brackets equal, or we can do them as power of a product. All right. So let's do product of a power. So we get negative 7 squared times 5 squared. That's the same thing. That's all I want them simplified. Next, we've got 24 divided by negative 6, all to the exponent of 4. Well, that just says 24 to the 4 divided by negative 6 to the 4. Now we've got power of a quotient, and we've got 78 over 13 all cubed. Well, we can just rewrite that as 78 cubed over 13 cubed. Pretty simple. Okay, let's finish it up here. We've got 3. We're going to combine all our laws together. So we got 3 squared times 3 cubed all cubed. Well, let's see what happens here. We've got, let's do our brackets, and we follow our rules from last class that we learned, and we have the same base, so we're going to get 3 to the exponent of 5 all cubed. And we're going to subtract, and inside here, when we multiply, we add our exponents if we have the same base, and we've got 4 to the exponent of 5 all squared. Now what we're going to do is we're going to use product of a power, and we're going to get 3 to the 15, we multiplied these, minus 4 to the 10. Right? I would like you to evaluate with your calculator. Have a good day.